I would like to check that I am audible and that you see this.
Yes. See the presentation, see you, can hear you.
Awesome.
Um, so we have probably 30 seconds left. But I guess I will go ahead and introduce you and you can get started right on time. So our next speaker is Stephen Jones. I will let him take it from here.
All right. I am a PhD candidate in John's lab here at the University of Michigan. I'm going to talk about mechanisms for event cognition in Soar. I've been thinking about event cognition for a while now, but I think I can do something about it. So I'm going to mostly describe event cognition. It's work in psychology, and then what it would mean to sort of model that in SOAR, and then I'm really just going to touch on the mechanisms at the end. So event cognition, I'm talking about human event cognition, has this notion of an event. And so that's seconds to tens of minutes of real-time activity within a context. So this is you waiting in line at Starbucks. All right, that's an event in your memory. So event cognition, that's how humans represent and think about events. Radvansky and Zaks, they have event horizon theory and event segmentation theory, respectively. I suggest you read the book on it if you want to learn more. So I'm going to be talking about how humans represent and think about events, but I'm a computer scientist, so I'm going to think of this in terms of data structures and processing. But first, why bother? Well, in humans, representations of events are used a lot of different ways. Summary, humans, we represent our previous experience in terms of the events that have happened to us. In action modeling, we're representing an action as an event where we have this notion of how it's going to play out. And planning, prospective memory, they really describe sort of, you imagine a sequence of events that's going to lead to a goal being satisfied in the future. Now, SOAR has had versions of summary, action modeling, and planning before, but I think that event cognition research can help improve SOAR's capabilities, and so I'm going to come back to these later. So humans, we represent events is what I've been saying. Well, I think that if you look at the event cognition research in psychology, they describe specific representations that I think of as different kinds of data structures. There's event schemas, there's event models, and there's the working event model. Event schemas, they're sort of your general notion of how a class of event goes. And so if you want some examples, that would be your action model for how a light switch works, or the general narrative for a betrayal. An event model, though, that's going to be a specific event. So that's your memory of having used the light switch earlier, or the narrative description of Brutus's betrayal of Julius Caesar. That's a specific event. The working event model, though, that's what this theory refers to as like your model for the here and now. It's the current event that's happening for you. So this is, I just turned on the lights, or boy, it looks like I'm next in line to stab Julius Caesar. That's your working event model. So these are the representations that event cognition theory uses to describe what's going on in humans. So you could think, all right, how would we fit these different kinds of knowledge in SOAR's memory systems? So just to give a little overview, we imagine we have our perception coming in, we have our central working memory here, we're able to control actions, and then we have our long-term semantic memory, sort of decontextualized facts get stored here, the log of experience, that's the episodic memory, and that's actually what I'm going to focus on for now. So where would these data structures go? These are things described in psych research, but I think they fit very naturally in SOAR's existing memory systems. So the working event model, that's your representation of what's going on right now. And it's what you use to direct your action. And so that means it has to be not only in working memory, but grounded to your perception and action. Now, these other structures, your memory for previous specific events, well, that's naturally going to fit in episodic memory. But then if you have this notion of, I don't know, people have been talking earlier in the day about declarative action models. I think that's very much like an event schema in this psych research. So I think that belongs in semantic memory. But for either of these to be used, they'd have to be retrieved into working memory. No, that doesn't make them part of your working event model. It just means you can think about them. So I think that's going to be important. Now, I've really been focusing on the data structures so far, but I'd also like to talk about the processing. However, this is a little busy, and what I'm going to do first is talk about the processing that event cognition says needs to occur, and then I'll try to figure out how that fits into SOAR. So I'm going to go with my simpler diagram here. I have a working memory, an episodic memory, and a semantic memory. How can we think about the processing that's occurring with these data structures? Well, let's imagine we have a little Roomba robot, okay? So it's trying to it's representing, I need to get to the next room. That's its working event model. That's its life right now. Event cognition research says that as you're going along, you're storing your working event model, and that the storage you're doing, it's in terms of individual events. And they say that there has to be a segmentation mechanism that's sort of saying that's the end of that event. This is the beginning of a new event now. And so that's how you get units or segments that are events that get stored in your episodic memory. And so we imagine we have our little robot and all of its previous navigation, that's stored in episodic memory. Well, maybe the robot needs to figure out how to do something, and there's knowledge of a similar instance from the past in its episodic memory. So you have to have some form of retrieval to get that similar room entry, because the robot's trying to figure out how to get to the next room. Just because you've retrieved that, though, that doesn't mean you can do anything with it. There has to be some sort of processing that actually shows how that's analogous to what's going on in the current situation, so the agent can use that in its working event model to actually direct its action. Now, there's also going to be maybe the potential for the agent to learn as a result. So, oh, it turns out I could probably generally use a good model for how to get to the next room. So we should have a way to learn new action models that generalize previous instances. So there should be a way to learn these new event schemas. And so in this case, this would be an action model for how to get to the next room that the agent would hopefully learn. Event cognition research also describes that we're not only using this sort of instance-based reasoning. Sometimes you have an appropriate action model. And so if you're in the right context, you'll be able to retrieve that model. So here I suppose that my little Roomba has an action model for just how to pass through the doorway in general. But once again, that retrieval is not enough. There has to be some process that actually grounds that in to the agent's representation of the current situation. So this is my model for the processing that has to go on to implement what psychology research calls event cognition using SOAR's memory systems and representations. All right. So why do all this? I brought up summary, action modeling, and planning before, and I think that I'll be able to expand on SOAR's capabilities with this kind of implementation of event cognition. So summary, that's the ability to represent your previous experience efficiently. And I think that by representing in terms of events, representing in episodic memory these sequences of events, we can have more efficient summary. Action model learning, this is the ability to initially create an action model and then also to be able to adapt that action model over time. I didn't get into that exactly. I'll cover it in a couple of slides. But the idea is that if you have an event schema that you've learned, you should also be able to, as you have more instances of use of that schema, you should be able to improve it over time. And then there's this other capability. It's related to planning, and I think event cognition can help bring this capability to SOAR, and that's anticipatory thinking. It's the ability to plan in advance. You can think of it as prospective planning, and that's another one I'll cover in a couple slides. All right, so let's talk about each of these capabilities in turn. Summary. So if I look at my little model here, what's doing summary? How can we provide this to the system? Well, I think the processing here that sort of enables an event cognition like summary that we see in humans, that's going to be this segmentation-based storage and the ability to retrieve a relevant event from the past into memory. And so I think this motivates new mechanisms in Soar. First of all, there has to be some way to initially segment the experience into events. Right now, we just have time step, time step, time step, time step in a continuous stream. And so I think that if we have surprise metadata in episodic memory, that will allow us to be able to mark like, oh, that was a surprising, well, I wanted to say event, but I'm not going to overload the words. That was surprising. Let's call that the beginning of a new event. And if we have these segments in memory, we have to also then be able to retrieve not just single time steps, which is how we do retrieval now, but segments of time. Sort of what changed between two time steps. And as a result, there's also going to be some changes I want to make to the query interface, which will include first, the ability to ask for what occurred between time steps. But then while I'm at it, some other things like go back to when X was just about to happen, or skip to the next surprising thing, because why not? So that's summary. Now what about action model learning? I want to describe what I mean when I say action model learning a little more. When an agent retrieves a similar previous instance, and it can actually use that to figure out what to do in the current situation. And then it generalizes that to learn an action model. That's sort of the initial creation of an action model. I don't really depict it here well, but you can also have an action model that's been retrieved. It was an event schema, and it was useful. So that's sort of a new instance. And that could also then be stored and associated with the existing schema in semantic memory so that we have sort of more data. We accumulate instances over time. So it's two forms of learning. The mechanisms that I think could support this in Soar, episodic memory seems to be the candidate where I would be able to track when a semantic memory schema was used. There's kind of some support for this in the system right now, not really. So I'll have to improve that. If we're storing instance knowledge to semantic memory that I want to associate with these schemas, I need to be able to retrieve in a way that sort of combines those instances. And so I think we need a blending mechanism, kind of like the one in ACT-R, that will combine these instances together. And then there's some secret sauce here that I didn't talk about. It's not in event cognition research, but I realized, oh, we need this. If I have my Roomba running around, how does it figure out to explore in the first place, right? It needs to be able to generate goals so that it's motivated to do any exploration. Otherwise, it will just sit there. And so I think that episodic memory can help provide goal suggestion. It can say, hey, you know what? This would be a cool thing to maybe try to do. I'd be happy to talk about that one offline, but it's less related to event cognition and it's a little bit complicated. All right, anticipatory thinking. First, I'd like to describe what this capability is in a little more detail. The people who do research on anticipatory thinking say, they repeat like that army phrase, what is it? Plans are worthless, but plans are nothing, but planning is everything. That's how these people think when they talk about anticipatory thinking. You're planning in advance. Maybe that plan's not going to be useful, but the idea is maybe you get lucky and you create a useful plan. So a good way to think about this is right now, Soar, if we have our little robot and it issues a motor command to go forward 5 feet, there's a good 3 seconds there where Soar's doing nothing. We literally have a wait operator where nothing happens. And when Soar encounters a problem, Soar reactively tries to plan, like, how can I get out of this problem situation? Well, wouldn't it be nice if we spent those 3 seconds instead saying, how could this go wrong? Let's plan as if something wrong happened. And maybe you don't use the plan, maybe it all works out. But anticipatory thinking is the capability to shift what would have been reactive planning later into proactive planning ahead of time. Okay. Whew. So what does this have to do with my model of event cognition? Well, in the past, we've studied prospective memory, where we can have spreading activation, say, hey, here's knowledge that might be relevant given this context. And I would like to build on prospective memory that we've already done in Soar. And so really all this comes down to is I need to redesign the wait. When Soar agents are waiting around, they could be planning proactively instead. So I think if I have all these other mechanisms to support event cognition so that the agent can actually think in terms of, it can model its environment and what it's doing in terms of events. It can say, all right now I don't need to do anything, but given my model, the event that's going on right now, I have an idea what's going to happen next. So let's plan for that. So those are the mechanisms I propose. And my nuggets, well, I actually presented some of this at a workshop on anticipatory thinking, and they seem to think it made sense. I like that this motivates new mechanisms for the architecture, and I've done some of the implementation. It turns out the episodic memory indexing structure, it really doesn't need to change much. Looks like it's pretty much okay. And this can build on the existing work, prospective memory, instance-based learning, planning. The goal here though is I got a lot of work to do. And I guess that's not really a goal, but I'm lazy. All right, that's what I got.
Okay, thanks, Stephen. We have a few questions here. The first one is from Nate, and he asks, why should it be the case that an LTM suggests goals in the absence of other knowledge or reasoning?
Yeah, so in other words, why would I have like a goal suggestion mechanism that EPMEM's spitting out goals or something?
Yes, so why
Okay.
would a long-term memory need to spit out goals?
Got it. Well, I'm sort of modeling a little bit, I guess, development. Right now I'm going to sort of speak in terms of the agent I've been working on. I have an agent in an environment where it navigates between rooms. And as a baseline for exploration, I can tell it to do random motor commands. But I would like for the agent to have more, I guess, intelligent exploration beyond just selection of random motor commands after it's accumulated knowledge in episodic memory. So I propose there can be a mechanism in episodic memory that says, hey, this would be interesting to have as a goal. Maybe you should try to do that. Best answer I have right now.
Okay. Another question from Keith. How does the mechanism of association or alignment take place? Is it an entropic constraint in the Shannon information sense or something else?
Okay. So if I go, I know this is a little busy, but it's the easiest one for me to get to. Talking about alignment here. I'm assuming we've already retrieved an event model. And the idea is, okay, how do I actually use that to describe what's going on in the current situation? Right now, I'm actually just imagining that with rules. The agent just saying, like, this is like instance-based learning reasoning. What's my theory for how the previous situation is analogous to the current one? So in terms of like, say, information theory, something like that, that actually might be related to my goal proposal mechanism, but no, it's not related to this.
Okay. Another question from Bob, does event cognition include nesting? So events within events?
Yes. Yeah, so events are hierarchical. I didn't really touch on that here, but they absolutely are. In fact, some computational models of event cognition, like that they've done in the psych research, they ignore the hierarchy sometimes and they call themselves out on it. They're like, this is bad, but it's what we wanted to do for now. I don't plan to ignore that.
Okay.